Barnes with ESA assisting here, as well as John Porcello with GSI is also on the line. And John's been working in the basin also for many, many years and may help me with answering some of your questions, but look forward to your feedback. All right, so we've got a combined presentation, groundwater, surface water interactions, and potential groundwater dependent ecosystems, or GDEs. You may recall this from our last workshop where we talked about the basin geology and groundwater conditions. This workshop is focused on the groundwater, surface water interactions and GDEs, and then the future workshops you can see here stacked in this pyramid as we move toward getting the GSP prepared. So we look forward to your input. It's all based on a foundation of having the stakeholder engagement and dialogue. So we're going to talk about what is the meaning of interconnected surface water and groundwater, specifics about interconnected surface water and groundwater in the Santa Clarita Valley. And we'll have an opportunity for questions. I'll turn it over to Tom, who's then going to talk about the potential groundwater dependent ecosystems. He'll also talk about next steps for follow-on work, and then we'll have a chance for questions at that time as well. So, got a bunch of acronyms and terms that we're using in these presentations. I'm not going to go over all of these, but you can see a few of them here. AFY, or acre feet per year, which is 1 acre covered by 1 foot of water. You'll see references to GDE, or groundwater dependent ecosystem. Groundwater elevation is going to be referred to quite a bit. That is a measurement of depth to water in a well that's converted to elevation of the water surface above mean sea level, so that we can compare water levels and river levels throughout the basin. Hydrograph is a water level elevation versus time plotted on a graph. Thalwag is another term we'll talk about. I'll show you some pictures of what that is. It's essentially the river channel bottom, the deepest part of the channel. And WRP, water reclamation plant. It's the water treatment facilities, Valencia and Saugus water treatment plant. So what is interconnected surface water and groundwater? Well, it refers to surface water that's directly connected at any point by a continuous saturated zone below the river or stream, connected to that underlying aquifer. It's in this basin, a major source of recharge to the underlying aquifers. Groundwater pumping can affect the surface water flows in interconnected streams. These interconnected groundwater and surface water areas may support groundwater dependent ecosystems. And this is a required element of SGMA and must be presented in the GSP. So first, before getting into the details of what's going on in this basin, just a few concepts I wanted to get across. This first one is, you see here, is I'm referring to a gaining stream. You can see we have the stream here, and then under that is the aquifer. In this case, the water table is above the river elevation, the top of the river here, and it's also above the thalwag, or the bottom of the channel. And in this case, in this example, that shallow aquifer is recharging or flowing into the stream. So therefore, it's a gaining stream. In the monitoring well that's nearby, the water table measured in that well is above the river level surface or above the thalwag if we're dealing with a very low flow situation. And we'll talk more about that. The flow from groundwater into surface water is variable. It depends on the groundwater depth and also the river stage. Here's an example of a losing stream. This is the case where we have river here, we have flow from the river into the aquifer. And this occurs when the water level in the aquifer, the underlying aquifer, is below the river level and below the thalwag in low flow conditions. This situation also exists in the basin. The recharge is variable, again, based on the elevation of the river versus, and also the elevation of the groundwater surface here. Lastly, we call this a disconnected stream, where during all times of the year, the groundwater table never reaches the bottom of the river or reaches the river in any way. If there's a continuous recharge or infiltration that occurs along this area from the stream down into the aquifer. This is called a disconnected stream. Recharge in this case is constant depending on how much flow there is in the stream. Moving on, this is a map showing the outline of the groundwater basin here in black. This is based on DWR's definition of what a groundwater basin is. We've shown here this blue line, which is the Santa Clara River, running right through it, flowing from east to west or right to left. We see here in colored areas, these are tributary drainages that are part of the Santa Clara River system. Castaic Valley with Castaic Reservoir, San Francisco Canyon, Bouquet Canyon, Mint Canyon, and the eastern end of the Santa Clara River drainage, and the South Fork area. I'd like to point out that we're showing the entire outline of the basin, and we're going to be talking about the basin in two pieces. One is we're going to be focusing on groundwater and surface water interaction from roughly, I don't know, this point over here all the way to the west. And the reason being is that you go east of this area, it's the river is continually losing to the aquifer system. It's either disconnected or it's losing, as I showed earlier. So we're not as concerned about supporting GDEs or habitat in this area as we are from this point farther, basically downstream of the Saugus Water Reclamation Plant. Now, for the purposes of the GDE identification that Tom's going to talk about, he looked over the entire basin in all of these areas in the tributaries. You may recall this from the last workshop. This is just a conceptual block diagram showing the position of the various aquifers underlying the basin. We have bedrock here, which is low permeability, virtually no flow. The Saugus Formation, which is a bowl-shaped formation that's quite deep. We see that there are a number of production wells and agricultural wells that pump from this aquifer. We have the alluvial aquifer, which is a thin layer of sand and gravel that sits on top. This aquifer was deposited by the ancestral or the even recent Santa Clara River flows. It's sand and gravel. You can see a number of the features of the water budget here that we've talked about before. But the main thing to notice about this is that on the east end, on the right-hand side of the diagram, is where infiltration from the river and its tributaries down through the alluvium down into the Saugus Formation occurs, a major source of recharge to the alluvium and the Saugus Formation. As we travel west or from left to right, you can see that we have the Saugus Water Reclamation Plant and the Valencia WRP here, which contribute water flows. There are other contributions of flow into the river, including treated water that's pumped from remediation occurring at the Whitaker Burmite facility. There's releases from Castaic Lake. We have releases from Bouquet Reservoir. We have irrigation return flow. All of this flow basically exits the basin here on the very west end at the county line. The key thing that you'll see later in the presentation is that we have recharge coming into the Saugus Formation on the east end, but the Saugus Formation flow upwells or discharges into the alluvial aquifer on the very west end. And that's a very important feature when it comes to gaining and losing reaches in the river and support for the groundwater dependent ecosystems. You can see here, this is another feature, this bedrock, this low permeability that the alluvial aquifer is kind of sitting perched on top of. I'd like to walk through some of the hydrographs, these water level elevation graphs versus time that we selected. This map shows a number of the wells that were included in this study, this part of the study. We picked these wells because they have a long record of water level measurements over multiple hydrologic or climatic conditions. So we can see what's happening during droughts, normal conditions, rainy conditions. We picked them also because they're relatively close to the river and allow us to basically compare the elevation of the water table in these wells relative to the elevation of the river bottom, the stream bottom, along the axis of the basin here along the river. That's an important feature because recall the elevation of the water table relative to the bottom of the stream channel is an important observation relative to whether that stream is gaining or whether it's losing in that area. There are some limitations, however, with the data sets that we're using. You can see that we have a number of large gaps between monitoring wells. That creates uncertainty about what's going on in between, and so we have to use a combination of monitoring data plus observations from the groundwater flow model that's been developed for the basin. We do have plans for installing instrumentation and pixometers in these gap areas to help fill in the information, but so far, for a number of reasons, we don't have permission to access these properties, but we plan to, and we'll be initiating monitoring in these areas hopefully soon. Other limitations are that these wells are, most of them are deeper irrigation wells. They're not shallow wells close to the river. And so that introduces some bias in the data sets. That being said, as I think you'll see from the data that I'm going to present, is that I still feel that the data sets that we have provide a pretty good indication of what's going on in the river and the dynamics between groundwater and surface water. This yellow arrow points to the well hydrograph that we're going to look at next. This is the furthest east well that we have in our study. And again, we did not look further east than here because these stretches of the river are always gaining or are disconnected. And so we're not as concerned. The habitats and the river connection with the groundwater system are from this point basically west. So here's VWD, this is a Valencia Water District well S7 that I'm going to show you a hydrograph for. Now just, there's a lot of information on these graphs, but you'll see them over and over and hopefully get a feel for it. So we have time on the bottom axis of each of these graphs, and we have groundwater elevation on the y-axis here, basically going from low elevation to high elevation. The green line represents the river thalweg, or the bottom of the river channel closest to that well. And the lines that you see here with the little diamonds, those are actual static water level measurements, or at least we think they're static. They may not all be static. And you can see the variation that's occurred here. This blue line shows you the discharge from the Saugus WRP between 2000 and 2020 in this range right here. And what we're looking for is what is causing this fluctuation that we see in the water levels. We plotted the same hydrograph on this graph below, showing the relationship with the rainfall trend. So going back up here, a couple of observations. One, you'll see that there's quite a bit of seasonal variability in the water levels every year as a result of just normal seasonal rainfall and dry conditions. Water levels on the east end of the basin fluctuate quite widely. It's almost like a bathtub where it fills up in the rainy season and it drains off, and we see these big fluctuations in water levels. We don't see much of a correlation here with the WRP discharge. However, we do see a fairly good correlation with the rainfall trend that's plotted here. Cumulative departure from mean average or average rainfall here. There's conditions here where we think that the river is gaining, at least during the period from 2005 through 2010, and then started, you can see with the drought, the water levels really dropped off. And then in 2017, we saw the water levels starting to recover, but still not at the river thalweg or the river channel bottom. So this well seems to be very influenced by the rainfall trends. Next, we're going to go to this well, this NLF G3. This is a Newhall Land and Farming well, G3, here kind of in the middle, just upstream of the confluence with Castaic Creek coming in here. And by the way, here's I-5, you can see that. Shows a little different pattern. So we see the river thalweg or the river channel bottom elevation here. You see that basically this is 2008 on the left-hand side. So from 2008 until roughly 2013, it looked like the water level in the well was above the bottom of the channel, indicating there was an upward potential for flow into the river. But then during the drought, it dropped off below the thalweg, and then when the rain came back, you can see the water levels rebounded. This blue line is the discharge from the Saugus and the Valencia WRPs. Not much of any, you can't see a correlation there. The flow is too constant. The yellow lines that you see here, these are periods when there were releases from the Castaic Reservoir. And there is a fair match on a number of these high points where there were releases and the water levels came up. In between, the water levels dropped and then releases. And then there's this long period basically between 2012 and 2017 where there were no releases. And the water level in this well continually dropped. So it may be a combination of a rainfall effect. You can see the correlation with rainfall down here seems to be a strong correlation with the water levels, but it also could be affected by the Castaic Reservoir releases. And again, in this area during the drought, we saw that the river appeared to be losing, or the water levels were below the river channel bottom. All right, next moving on downstream to well C4. And this well is it's close to the confluence where the Castaic Creek runs and discharges into the main channel of the Santa Clara River. We're going to take a look at that hydrograph. All right. Interestingly, you see that here's the river channel bottom, but the water levels don't get quite that high. Now, is that because the river isn't gaining there and it's always losing? Possibly. It could be a data problem with the elevation of the river bottom or the elevation of our measuring point on the well. We don't know for sure. We do see a strong correlation with the Castaic Reservoir releases in that well, as you'd expect, considering that it's close to the confluence with Castaic Creek. There does appear to be, a bit of a trend with rainfall, but not very strong. So there's something else going on here with these water levels this could be influenced both by Castaic releases, but also there are other wells nearby that could be influencing the groundwater levels in this area. So I think this hydrograph really points out some of the issues that we have in interpreting the data with a lot of complicating factors. Moving on downstream to well NLF B14 down in this area. Now it's a very different pattern. You can see the water levels in that well are tracking fairly well with the channel bottom. In fact, very close. In fact, it looks to us like the river is gaining in this area. We see some of these drops in water levels. Those could be non-static water levels. But overall, we see this fairly constant water level down here. We don't see a strong trend or tracking of the rainfall trend with water levels. There's not a strong correlation there, and there's not a strong correlation with the WRP flows. Based on our work and some of the work you saw in the last workshop, we think that this area is influenced by flow upwelling coming up from the Saugus Formation, that deep aquifer, up into the alluvium, which then is supporting water levels in this area. And I'll be showing you a map later where we think that's occurring, but that's probably the biggest reason why the water levels are fairly constant and don't seem to be affected by the rainfall trends. And next, lastly, I'm going to show you this well that's just outside the basin. This is 27B. I'll just, if you can't see that label right there. This is just past the basin boundary. It's just past the start of what's called dry gap, where the alluvium, that sand and gravel deposit, starts getting really thick again. And we have a long record of water levels for this well. So that's one reason I wanted to show it to you, just to give you some perspective. So again, 27B, green line is the river channel bottom elevation that we've estimated. You see that in many years, that water level in the well is very close to the bottom of the river channel. There are periods of time, and this is 1980 on the far left through 2020. So there's a good long record. You can see the WRP's flows increasing in the upper basin in our area steadily during this time. Interestingly, you know, it's difficult to see what trend or correlation there is with the WRP flows in this graph. You look down here on this is the same water level data, but we're taking it out to 1950. 1950 is out here on the left and 2020 over here. So it's the same data, except we've got more data to look at. You can see these pretty significant declines in water levels that we think were occurring as a result of predominantly agricultural irrigation that was going on back in the 50s and 60s. You can also see these are the rainfall trends here that we're showing, and there seems to be a pretty strong correlation with the rainfall trends. Here, for example, in 2011, 2012, when rainfall was way below average, we had that big drought. You see the water levels really dropping off, and then when the wetter conditions return, we see the water levels coming back. So from there, I'd like to show you our interpretation using those water level hydrographs, using the groundwater model, and just visual observations of the areas that we think in the basin are either gaining or losing under different conditions: wet, normal, and dry conditions. So in this map, and again, here's the Saugus WRP right over here, and we're tracking what's happening with water levels and inferring what's happening along the river. And so during the wet conditions, we believe the river is predominantly gaining throughout most of its reach, most of its length in the basin here, with the exception of this area, which we call Reach 5, just down at and downstream of Potrero Canyon. This area we think may be actually losing simply because the area above it is receiving flow from the Saugus Formation underneath. But this area is sitting on top of that low permeability Pico Formation. And so it's not receiving any of that upward upwelling of groundwater. It's just flowing across that bedrock surface down past the county line. And then based on what we see down in this end of the basin, we think this is also a gaining reach in this part. When we go to the normal conditions, we start to see things change, average rainfall conditions. So just downstream of the Saugus WRP, it looks like the river is losing, but then as we approach the I-5, there's indications that it actually might be beginning to gain again, and then lose again after that is past the Valencia WRP, but then picks up again here in this area where the river appears to be gaining. There's an important reason for some of the dynamics that you see here, and that is that alluvial aquifer that underlies the river is not uniform thickness everywhere. It starts to thin out over here near Round Mountain, near where we've seen upwelling of groundwater in pools beneath the I-5 bridge in this area, even during dry conditions. You can see down here, this reach number 4, which is in blue. We think this is continually gaining in part because of that upwelling of groundwater discharging out of the Saugus Formation, that deeper aquifer, up into the alluvium. And then from Potrero Canyon on down, we think it's losing again because it's flowing, the groundwater is flowing on top of that low permeability Pico Formation bedrock and then losing down here during normal conditions. Dry conditions. Virtually the entire length of the river appears to be losing based on the information that we have, except for this little spot right here underneath the I-5 bridge where I know Tom Barnes and John Porcello from our team observed flow in some pools in here, some upwelling, in part because of the thinning of that alluvial aquifer there and because of a rise in that Saugus Formation bedrock here. That then it quickly becomes a losing reach until we get down in this part of the basin in the vicinity where it shows blue, where it appears that the Saugus Formation is discharging to the river and supporting the water levels in this area. And then during dry conditions, again, we see that both of these reaches, reach 5 and reach 6, are predominantly losing. So obviously we could benefit from having the rest of our monitoring points installed, and so we'll be able to improve the picture quite a bit. We're also going to be using observations from the groundwater flow model, which has the ability to look at changes in stream flow and groundwater flow at different points along the river. And so you're going to see that in the next workshop. You'll probably see some information presented on that. So the last part of my presentation, I'm just going to quickly cover the relationship between river flow at the county line, that far western gauge, surface water gauge, compared with precipitation in the basin, WRP discharges in the basin, and pumping in the basin. And again, this is only at the gauge at the downstream west end of the basin. So what you're seeing here, we've got data from 1950 to 2020 across the bottom here. This is average flow in acre feet. On this vertical axis, the y-axis, acre feet per month, you see these purple lines represent the time when the Saugus and then the Valencia WRPs came online. The green and then ultimately the gold represent the non-storm flow, basically the summer flow across the county line as measured at the gauge. This does not include the peak flows, which are quite a bit higher than this. And so you see the precipitation data here. I'm sorry I didn't mention this. The blue bars are at water year precipitation measured in the basin. And you see this rising stream flow measurement at the gauge. It does not appear to be related to rainfall changes. You do see seasonal changes, and these spikes seem to be related to conditions where we did have elevated rainfall either that year or the year before. But overall, the trend does not, this rising trend does not appear to be related to rainfall. We go to the next graph, which is again the 1950 through 2020 graph. And again, I'm showing you the stream gauge data at the county line again. And these blue bars are representing the WRP discharges, the water reclamation plant discharges that started basically in the mid-60s and started increasing. And you can see that with urbanization, importation of state water, more water being discharged from the water reclamation plants, there's been a steady increase and then a leveling off, which seems to have a correlation with the gauge data at the county line. It's not the only factor, but there seems to be a correlation there. And then lastly, monthly stream flow versus all the east subbasin pumping. This is alluvial aquifer and Saugus aquifer combined pumping by water year that you can see here in the orange bars. Pumping data from roughly the mid-60s back is estimated based on acreage of land that was cultivated But you see, at least based on this plot, it's not evident that there's a strong correlation between the stage or the flow in the river and pumping going on in the aquifer. It doesn't mean that pumping doesn't affect the river, but it just shows that this increase appears to be related to, or the changes appear to be unrelated to the pumping in the basin. So with that, I'm happy to entertain questions, or if you, Tara, if you want us to continue through the presentation, I can turn it over to Tom.
I'd be happy to take over and handle Q&A, though I did not see a ton. I'm sure there will be now. There's more comment, I think, than questions at this point. So kind of getting to the comments first, because I think those we'll just record those, and then we'll also add them. And if you would like to address them, you can. But otherwise, we'll just add them to the discussion and feedback. Sandra would like to say the east side of the river is not always disconnected. They do get some rain. So that's something to note or have an idea of or address.
Well, I can respond to that. Yes, there is rainfall that contributes to the surface water flow, but it's infiltrating downward to the groundwater table. It's recharging the groundwater on the east end versus the groundwater table rising up and flowing into the river. It's a different dynamic on the east side.
Sandra, does that answer your question?
Yes, but a follow-up is, how do we get data on those eastern wells to find out? We now have really good historical data from the wells near Interstate 5, but I know that there used to be producing wells on the east side, and now they're not producing. And it would be helpful to have data on the groundwater levels on the east side and to find out what's been happening with it.
Okay. All right. Fair point. The wells on the east side, you know, the Pine Tree well field, for example, did have trouble during the last drought and during low flow periods, no doubt about it. They've had to shut down a number of wells, but many of them are still operating. And we could certainly paint a picture of what's happening with climatic changes and river flow changes relative to the groundwater levels in that area. We could look at that.
And I think that ties into Kathy Armitage's question as well, which is how can we supplement the data collection process to get a better understanding of how the releases from Castaic Reservoir are affecting the well levels. This seems like an important piece of data to understand well, and or for if/when we receive less surface water from the State Water Project.
That's a great question. So if any of the SCV staff on the call want to help answer it.
Dirk, this is Dirk Marks. DWR maintains a public database for releases from Castaic Lake. It's the California Data Exchange Center. And there's a station there for Castaic releases. Its identification is CAS. And you can get yourself custom graphs of water released out of Castaic Lake from that site. And I can follow up with a link to her at a future time.
Dirk, I'll add one more thing, and that is that we do have water level data from wells further up Castaic Creek that I did not show as part of the evaluation. But those water levels and the relationship to Castaic releases are captured in the groundwater flow model that we've put together. And so we can spend a little bit of time on that later on when we get to that topic.
And finally, that kind of all these questions really tie in well together. So finally, Candace Lee says, how much will it cost to install those monitors that may improve or will improve the data collection? Is GSA planning to get them?
Well, we are fortunate in that SCV did apply for a grant from DWR to install and monitor the that I spoke of. So virtually all the probe installation and the monitoring, at least for the better part of the year, are covered by grant monies. It's just a matter of getting the access to the properties to install them.
And then Sandra wanted to add one more question of, do the Bouquet Reservoir releases have any effect?
Well, you know, when we're talking about releases on the order of a couple thousand, 20, to 3,000 acre feet per year, but more recently, a lot less than that. Sure, they have an effect. They are captured in our groundwater model and the water budgets that we've put together. So it's included with all the other components of inflow into the basin. As far as the significance of those flows, I just have to compare it to other flows and other discharges like WRP flows or other sources of recharge to the basin, and it's not that significant. But it is a factor that we've included in the water budget and in the modeling work that we've done.
And those are
I have
all
a question.
Oh, yes.
Hi, this is Stacy Fortner. I'm gonna kind of piggyback on Sandra's question because you're stopping at number 7, but it's the upper watershed that we need the reporting on, because it wasn't just the Newhall well field that went dry in the last drought. The center well went dry, and another well up Bouquet that is a Santa Clarita Water District well went dry. So how do we get more information included in these reports and go past number 7 and get that upper watershed reports and included in this data?
Well, okay. I think, first of all, it will be included. And I know John Porcello is on the call right now, and we will talk about this when we get to that next topic. But for this topic, we were concerned about groundwater surface water interaction, where the river is gaining or whether it's losing in the areas of where we have a lot of habitat. That's what this particular presentation was focused on. There's a lot going on up in the tributaries and further up into the basin, we understand. Those issues are going to be captured in a couple of places. One, as I mentioned, in the modeling work, but also as we characterize groundwater conditions, which was the topic of the previous workshop. We can spend a little more time making sure that we cover what the groundwater conditions have been up in those upper areas. I think that's an appropriate place for that.
If I could add one thing, Jeff, it's Dirk Marks. There is also an annual SCV water report that's available on the SCV water website that has water levels throughout the basin, including those on some of the wells that Sandra was commenting on. So that, then there's a long history there of reporting that data.
Thanks, Dirk.
And then we have one new question asked via chat. Can you please elaborate on the effect of groundwater remediation near Whitaker Burmite?
There are probably some people on the call that know more about the details of that remediation and what the flows are. And so for any of those folks that want to chime in, but in general, the remediation that's going on at the Whitaker Burmite site is on the order of hundreds of gallons a minute that then is the treated water is then discharged to the river. We have some other locations where water from SCV wells has been treated after treatment discharge to the river. And so we've been trying to capture those flows as part of the groundwater modeling exercise. As far as it being significant to the overall flow in the river and dynamics that we've just been describing, we don't believe that it's a substantial or significant element that would change our interpretation that you've seen here today. But they are sources of flow, just like with Bouquet Reservoir, that are included in our water budget in our analysis.
One more question. This is Stacy. Stacy Fortner. When are you going to release the water report from last year? This year, are you going to release last year's water report this year? Aren't they normally out in the May-ish timeframe?
This is Dirk Marks. Stacy, yes, we are running late in getting that report. It just got into our office this week, so I anticipate that it will be posted within a week or so.
Okay, thank you. So that's the 2019 report will be posted this week or next week?
Probably by next week. Yes, 2019 report.
Okay, thanks. And then when will 2020, when can we expect the 2020 report?
Well, I would hope that it would come out during the spring of 2020. That has been the goal that we've had in the past, but and that's what we're hoping for 2020, it's spring.
Okay, thank you.
Sure.
All right, I don't see any more questions in chat. Does anyone have any questions that they'd like to ask? Does not seem like that's the case. I think we're done with questions for this round. So moving on to the next speaker, Tom Barnes. There he is.
Can you see me? Hear me?
Yes, we can see you and hear you.
Great. So Tara, do you want to run the slideshow, or shall I share my screen with the slideshow? How should we do that?
Tom, I've got the slideshow up if it's the same that was posted.
It is indeed. So if you, I'll just say next slide as we go through, and that's okay.
Yeah.
Right. My name is Tom Barnes. It says Tim Barnes on some of the.
I changed it. I changed it.
Oh,
It's
did you?
not. Yeah, you're Tom all the way.
Okay, that was a little typo. Sorry about that. But Tom Barnes, Environmental Science Associates, is a consulting firm, and we are supporting the GSA here in trying to understand where the groundwater dependent ecosystems exist in this sub-basin area, the upper basin area. So so I have a brief presentation on a process we went through to identify potential areas of groundwater dependent ecosystems, areas of interest for sure that we'll continue to look at into the future. So I'd like to just sort of present that process today of the report. And as Tara said, the ultimate product that we produced is available on the website, that zoomed in KMZ file, Google Earth file, where you can go anywhere on the Google Earth and see where within this basin and see where we've identified vegetation mapping associated with vegetation types that need perennial groundwater sources. So that's a neat tool, that's a neat product. Starting out here then is the Santa Clara River watershed. It's quite large compared to our upper groundwater basin. So I just thought I'd start with that. We'll, our vegetation is sitting on the surface, but we're just looking at the area in the blue here. So next slide. We are doing our work to comply with the Department of Water Resources SGMA requirements. And so this is, the title of this slide is Alphabet Soup. but I think we mostly understand what it is. It's the Santa Clarita Valley Groundwater Sustainability Agency. Their SIGMA and GSP, the Groundwater Sustainability Plan, requires groundwater dependent ecosystem identification. So a lot of alphabet soup there, but just a lot of information in one little title. Basically, we're doing GDE identification within this basin. And it's a requirement of SIGMA that just asks that GSPs are considered and impacts to GSPs are considered, or impacts to GDEs are considered in the plans. Now, that's about what DWR has to say about it. SIGMA, I saw that little comment chat come in. SIGMA is the Sustainable Groundwater Management Act of California that was passed, I think it was 2014, is that right? So the Nature Conservancy has taken upon itself to provide really excellent guidelines for preparing GSPs and for identifying GDEs in particular. So although the DWR requirements don't really get into the details, Nature Conservancy does a great job of a roadmap approach. And so we followed that approach, at least initially starting the approach. We're really only on step 1.1 that we're reporting on right now. So we're just in the very beginnings of the process, but we have mapped the potential groundwater dependent ecosystems within the basin. And so I'll walk you through how we've done that. We haven't characterized their condition per se, because we feel that when we have identified these habitat types, they're generally going to be of value, of interest, and their existing condition can vary widely, and it's a very large area. We haven't done that yet. There's certainly room to do that. Nature Conservancy suggests that might be helpful. Step 2 of their process then, leads to the determination of effects of a management plan on those ecosystems. So really doing an impact analysis on the ecosystems is part of this GSP. And then the GSP needs to consider those GDEs when establishing management criteria. So as those criteria are put together for how a groundwater basin can be sustainably managed, you have to consider ecosystems that might be affected by groundwater. Step 4 then is to incorporate the ecosystems into a monitoring network moving forward. And then step 5, really identifying management actions or projects that would maintain or improve GDEs. So that's not a regulatory process, it's a roadmap, a guideline prepared by the Nature Conservancy. It's quite helpful, it's quite comprehensive, and we tried to follow it as we could. Next slide. And really just initiating that process. So this slide defines 4 products that we've prepared, these 4 large bullets, the KMZ 1, 2, 3, and 4. The KMZ is a file name for those Google Map data pictures. And so I will show you details of those pictures after I've described what they are here, 1, 2, 3, and 4. The questions to Jeff about the eastern part of the basin watershed, I think are really relevant to our process here. We looked at the entire basin and compiled existing vegetation mapping. So there's been a lot of great work done in the last 10 years from a lot of different sources that have been compiled by DWR into a data set called the Natural Communities Commonly Associated with Groundwater data set. It's also known as, or it's similar to an IGDE data set. So that's publicly available vegetation mapping data. And we were happily able to use that data set and really pleased with how comprehensive it was for this particular basin. Oftentimes that data isn't as comprehensive. So we had a really good head start in this watershed based on work that a lot of folks have done over the years and compiled into this data set. What this data set shows us is where vegetation is occurring that is groundwater dependent, essentially vegetation that needs perennial water sources. And that perennial source could be surface water, but in these arid, semi-arid region that we live in, it's likely when you find these types of vegetation that we'll talk through, the willows and the cottonwoods, that you've got some perennial sort of consistent water source. And so by following the vegetation, by mapping the vegetation, we really get a good sense for how close the groundwater is to the surface, based on this sort of already stress test watershed. And we all know that we live in an area with very dry hills and we can have very dry arroyos. And so that's an indication that groundwater is not making it to the surface shallow enough for the root zones. So we compiled the existing data, and then we did some aerial photograph reviews and checked that. We sort of quality controlled that and changed some of the polygons associated with the data that we received to match aerial photographs. And we added some gaps as well. Sometimes there was no polygons in areas that had just a dry wash type of a barren dry waterbed without any water. So then in the second bullet here, the KMZ2, we is the result of a field test. So we went out to many places. We didn't do obviously every square inch of this large watershed, but we went to areas where at least one of multiple habitats were shown on the maps, and we could really get a sense from a biologist's perspective that the original mapping that we had was comporting well with what we could see on the ground. So we did spot checking in areas where we could really determine if the habitats were indeed shifting as indicated by the mapping. We also went to places where the hydrology was a little bit unclear, and based on aerial imagery analysis, we wanted to go see what type of trees those really were. And so we went and did some field verification. That's what I will show you in KMZ2 what that looked like. And then in KMZ3, we refined the data and really separated out vegetation types that are associated with groundwater or perennial water sources, and those that are not. What we call upland habitats, or grasslands, or hillside scrubs, or barren river washes. But there's a lot of Riversidian sage scrub habitat in this watershed, and it survives on the hillsides and on the edges of streams when they are dry. And so we removed those habitats from our GDE map. We also removed man-made features like the golf course ponds. Castaic Lake shoreline was removed because of the man-made perennial water sources. Finally, then in KMZ4, it's pretty much the same as KMZ3, but we've just reclassified the definitions of the habitat types to match the Manual of California Vegetation, which is what California Department of Fish and Wildlife likes to see. So we've just made it so that standardized essentially the vegetation classification. Okay, so I'll go through now the pictures, next slide, that explain those 4 different KMZ files. KMZ1, this is the original data set. So you can see lots of variability, diversity, and habitat types. Looks like a really robust and healthy data set. And we started with a nice array of data. This is, in order to see it clearly, I've zoomed in just here on I-5, you can see, and that going through down the middle, and that's Castaic Creek coming from the down the center, and then San Francisco Creek coming over on the right. So I've zoomed in here so that you can see it, because when you have the whole watershed, it loses the definition. So this is where we started with some really nice data set of existing vegetation diversity. Next slide. KMZ2 then, we field verified and sort of separated out habitat types between what would be associated with a riparian or perennial water source, such as the dark green here, which is a riparian mixed hardwood vegetation, which is willow trees and cottonwood trees mostly. And then the yellow is an alluvial scrub, meaning more of a drier habitat type. And the pink here also is scale broom, which is associated with an upland, or that is to say, a drier area where you the root zone is not associated with perennial groundwater. And so here we've been able to really make our first real cut between areas that are exhibiting evidence of a closeness to groundwater and areas that are not. Next map, please. And then KMZ3 has removed those upland areas. And really we've kept the riparian mixed hardwood and riparian mixed scrub. And we've also kept the coast live oak. Coast live oak tend to live up in the canyons. They often have pretty long roots, and they're often fed by seepage coming out of a higher formation or in a ravine. That is a groundwater dependent type of vegetation. So we've kept it in here into the canyons. And the KMZ, you can really zoom in closely and see exactly where these areas of coast live oak occur. Next slide is KMZ4, which is basically the same map, but just kind of condensed into the manual that of classification that CDFW has generally requires. Okay, so next slide then shows the whole watershed in one slide. And you can see that it's hard to see definition on this scale. So that's why I have showed the last 4 slides close in to the I-5. But I would like to show you sort of how it works. One of these northern peaks, that if you want to just circle Bouquet Canyon, Jeff, up on the top there, it's one of those upper canyon areas. So that's San Francisco. Go over to the right there over to the other side. There you go. That's Bouquet Canyon. So next slide. If we look, it will be a close-up of that area, and you can see that we have identified, based on those original data of vegetation mapping and all the process that we went through for the Nature Conservancy guidelines, to see what is existing there. And in that Bouquet Canyon, you can really see that although there is some vegetation that is perennial and that is being fed by some source, we're not exactly sure what. The question about does Bouquet releases affect the groundwater in these areas? It's hard to say. These indicators that there's vegetation out there, this could be surface water fed from the agricultural runoff, or it could be access to a groundwater or perennial seepage in this area. So we have kept everything that we're not sure about. So we've identified where these habitats are existing and haven't really necessarily defined how they're getting their water. We're calling them potential GDEs because of the type of vegetation that's there. Next slide. So back again to the whole watershed and showing the large extent. I'm going to go now zooming into the southern fork, which is down there in the bottom, just to give you again an indication that we've tried to capture pretty good detail and granularity in this data set. So here we have coast live oak woodland and the Fremont cottonwood forest in green. And you can zoom even closer if you want and get down to the street map level and really see where that vegetation is. So it's hard to see on a screen that's on a computer, but it does have a good definition to it. And again, these are potential areas where that root zone has access to groundwater consistently. Next slide. So then our next steps, we've submitted this preliminary report that shows potential groundwater dependent ecosystems. And it's really based on the vegetation in the basin telling us that there is some water source there. So it's still a potential GDE. There might be some of these areas that are being fed by surface runoff, either urban runoff or some other kind of discharge. Our next steps is to look at groundwater depth, and you know, we could overlay groundwater depth right now and see if we could eliminate any of the areas that show vegetation now based on depth to groundwater. But we're not sure that that's a good idea because groundwater levels vary a lot, and seasonally and hydrologic year, there's a lot of difference. And so we feel that showing the potential for GDEs based on the habitat type is the best way to go now, and to really continue the monitoring into the future as groundwater management plans are prepared. Also, I think there's more room for refining the ecosystems here based on the gaining and losing segment work that Jeff's doing. Areas that have perennial gain discharge water into the creek that then goes downstream, and that water then waters root zones downstream. So there's connectivity there, but there's more work to do, I think, on really defining what is ecosystem dependent on the groundwater and what may not be. And then as again, you know, as the groundwater plan is put in place, management actions are identified to monitor groundwater levels and access to of plant root zones to perennial water and groundwater. That will determine the potential impacts. And so that's the next step in the whole process. So I think that concludes my presentation on the work that we did. And like I said, the KMZ is available online, and you can sort of zoom in and see where that habitat types show up.
I've unmuted myself, so that helps. So it seems like the only question that was asked in, oh, Kathy just asked another one. Literally, as I said, seems like the only question. So first, let's ask if anyone has any additional questions about Sigma. Does anyone have any questions about Sigma beyond what Tom already addressed? All right, so moving on to Kathy's other question, can you talk about what consideration was given to animal life that is dependent on the vegetation you identified as being groundwater dependent, since we're talking about ecosystems?
Yeah, I think it's really important to recognize that the work that we have done now and the mapping that we have available to us is an indication, it's an indicator of habitat that we value. And in Southern California, when you run into, you know, willow habitat and any sort of perennial aquatic habitat, there is most likely going to be associated some animals and sensitive species in particular that are relying on those areas. They've dwindled in our Southern California region compared to historical levels, and so the animals that are dependent on them are oftentimes sensitive species that we look at from an impact analysis. So the first step of identifying the footprint of vegetation that has been stress tested already over the 2015 drought that we just went through, and then just obviously longer time frame than that as well. It really helps us understand where the valuable habitats are, and their condition is important. And moving forward, I think we can work on what that means in terms of their condition and how they could be improved. But right now, we're just looking for the indications that they exist, and because they exist, we're going to have to monitor and look at them carefully, and not just because they're the plants, but because of the species that they support as well. To your point. Does that answer the question, you think?
That would be Kathy. Does that answer your question? Great.
Yes, thank you.
All right. And that was all the questions that were in the chat. Are there any questions live? Okay, with no additional questions, I'm just going to remind everyone, Kathy, can you, Kathy Martin, not Kathy Armitage, can you toss in the link to the website one more time so that we could remind people to go to the resource page? There's also a survey there if you could fill it out and let us know what you think about either the presentation or the plan as it's currently in its current state. We'd love to get some feedback from you. And we look forward to seeing you at our next, here, I'll start video so I can wave goodbye. So we'd love to see you at our next public workshop. We're so excited that these have been so well attended. So thank you so much for coming. Really, really happy to see everyone here. Bye. Bye, everyone. Hope you had a great educational adventure. Bye, green person. You seem really cool. Yes, an archived version of this will be online, and last public workshop is currently online, so you're welcome to check that out. It's all kind of in that link, so it'll be at that link potentially next week, because it takes a little while to like have these. They do something like importing or exporting, and it takes forever. So, and then we have to upload them, and that takes forever too. So that takes a little time. I'm going to stop recording now. I'm going to stop waving and recording.